In this video, I'll show how to track and draw trails behind one or more clouds in Barracuda simulation results. We'll do this by using this PyTecplot script that you can download from this support site post. And if you put it in your simulation directory, you can then open this script with the text editor. And the only thing that you should really have to edit in this script are these two lines. So there's a cloud ID list and a cloud ID base list. If you look at the notes in the top half of this header section, it'll kind of explain what those two variables mean. It'll also show you how to do either one cloud or multiple clouds, and we'll demonstrate both of those here. For this example, I'm using the pre-set-up Kuiper's example. So here we'll click View Results so that we can open up Tecplot. And this will start up with the default view of showing particles colored by volume fraction. In this case, to use this script, you do need to load all the data that you want to be analyzing, right? So if you want to track a particle through all time, you can do Tecplot files to load and select all, click refresh reload. That will load all time steps available from your simulation results. In this case, the default pre-setup for this Kuiper's example has about 200 files. So for the purpose of illustrating how this script works, I'm going to load fewer files, and I'm going to choose in evenly spaced, and we'll choose 21 files. And so if we do this, this will give us a results file every 1 second in simulation time. So we'll see 1, 2, 3, 4 seconds, and so forth. So we're just reducing the number of files that are loaded just to show how this script works. To use the script, you will need to enable PyTecplot connections. So we'll go to Scripting, Enable PyTecplot Connections, Accept Connections. You can either leave this box open or close it. It remembers the setting. And then in order to run the script, we'll go ahead and open a terminal from our Barracuda GUI that's open in the project directory with all the results files. And you will need to have Python installed. So see our Anaconda Python installation page. If you need to install that and configure it, you'll see here my terminal says I'm in the base environment, so that's indicating that I have Anaconda Python installed and it's ready to use. And let's take a look at this script here. The first thing I'll show is tracking a single particle. So let's say we wanted to track particle with cloud ID 10, and our base in this case is 0. If you have a simulation with less than 10 million particles, the base number will always be 0. But if you get into simulations that are larger and they have more than 10 million particles, then your base ID is going to increase by 1 for every 10 million particles that you have. And so by using the cloud ID and the cloud ID base, we can uniquely identify every cloud in the system, even if we have more than 10 million clouds. This is a small example, so all of these have a base value of 0. And so we're just going to track particle number 10. Okay, and so this is the default state you'll find the script in when you download it. We'll go ahead and run it. We'll say Python create particle trails by cloud ID, and then we'll hit enter. So here you'll see that it connects to the Tecplot session that's running, and we enabled the connections there. It is iterating through every solution time that is loaded, and again we loaded 21 solution time files, so the initial time plus the 20 seconds that follow. The script will output a little piece of information that could be useful for you in the future. It shows the equation that is going to be used for particle blanking, and so if you ever need to implement an equation like this, it's just outputting that for your reference. If we go back to the Tecplot window, what we'll see the script does is it actually performs the blanking for us so that we're only looking at the cloud with an ID value of 10, and it draws this path, or what we're calling a particle trail, in the system. So here, let's go ahead and back up to time 0, and if we start, so this is the particle's starting position in the simulation, and if we go time step by time step, we'll see that the particle starts moving along this path. And so that's what this path is showing us, or this trail is showing us where this particle is located over time. So if we look at this particular particle, it will stay on this trail for the whole time period that we have loaded. And so sometimes this is all you need, is to visualize the path that a single particle has taken. And if that's the case, then you can use this script exactly like this, specify the cloud ID that you are interested in and the base ID that corresponds to it, and it will create that single trail. I'm going to go ahead and close this Tecplot window, and let's open a fresh results window because I want to show the same sort of thing, but now we'll track multiple particles. So here we'll go to scripting, PyTecplot connections, let's accept those again. Let's reload the files that we are interested in. So we will load in evenly spaced, we'll use 21, refresh, reload. Okay, so now we have all of our time steps loaded in. We can edit our script here. So what I'm going to do is I'm going to track particles 10, 20, and 30. And the cloud ID list and the cloud ID base list both have to be the same length. So to have 3 particles tracked, each of them has a 0 as their base ID. So we'll put 3 zeros in this list. Okay, we'll save that file. And we'll go back to our terminal. And we can just recall that same command that we ran before. And we'll hit enter. One thing you'll notice is that if you have multiple clouds that you're tracking, then each time or each solution time will take a little bit more time to process because Tecplot is going in and finding the location of each cloud that we're asking it about. So if you wanted to track 100 clouds, it would take a bit longer than this, and if you wanted to track 1,000 clouds, that would take even longer. And then you get a lot of trails on the screen too, so there's probably some practical limit to how many clouds you really want to be tracking in this manner. Again, we can see our blanking constraint, the equation that was used. And so this is why this equation is output. Just in case you want to go and use it for any other purpose, you can always copy and paste it into the equation editor. Okay, so if we go back to our Tecplot window, we can see now we have 3 trails, 1 for each of these clouds. And so if we click through time, we can start to see how each cloud moves around. One thing that might be useful in cases like this is if you are going to be visualizing multiple trails, you might want to change their colors just so it's easier to tell which trail belongs to which cloud. So if we go to zone styles, this is under the edge zone, and if we make this a little bit bigger, we can see these are the 3. You'll see the zone names are actually named after what I'm calling the true cloud ID. So the true cloud ID is calculated based on the cloud ID and the base ID. So each zone should have a unique name. And so here we could say, all right, for cloud number 10, we want this zone to be red. And for cloud number 20, we want this zone to be green. And for cloud number 30, we want this zone to be blue. And so if we do that, we can start to maybe give a little bit more of an informative visualization about which trail belongs to which specific cloud ID. So that is the overall idea of how to use this PyTecplot script to draw these particle trails, either one cloud or multiple clouds from your Barracuda simulation results. And that concludes this video.